Hi guys, this is Jashwant Deshabana from Benito University. Today I'm here to tell you a topic called closure properties of CFL. So, what is CFL? CFL is nothing but context-free language. I hope you have some clarity about context-free language. Let me give you some more details. So, context-free language is generated by context-free grammar and it is accepted by an automata called push-down automata. Similarly, regular language is accepted by an automata called finite automata, but CFL is not accepted by the finite automata. Here the presentation: CFL is generated by context-free grammar and accepted by push-down automata, and regular language is generated by regular grammar and accepted by finite automata. Let's enter into our topic, closure properties of CFL. So by looking at this, you will get a doubt like what is closure properties? To get a good understanding on closure properties, I will explain you with an example. Let's take two CFLs, nothing but context-free languages L1 and L2. If we do an operation between both two context-free languages, then we will get a resultant. Then if the resultant is also a context-free language, then the operation is closed under CFL. Now let's see context-free languages are closed and not closed under some of the operations. Let's see that. And the first operation is union operation. Second operation is concatenation operation. Third operation is clean star operation. And these are the three operations where the CFL is closed under. In coming to the non-closed under operations, the first one is intersection and the second one is complement. These are the two operations where the context-free languages are not closed under. Let's start with the union operation and get more knowledge on that. Union operation. Let L1 and L2 be the two context-free languages, then the union of both L1 and L2 will also be the context-free language. It means if we do an operation between two CFLs, then the resultant of two languages is also a CFL. We'll understand more with an example. Let us take a two languages L1 and L2, and L1 is equals to a power n b power n, where n is greater than or equals to 0. We know that for every language there will be a grammar, so the g1 is equals to n1 t1 p1 s1. n1 is number of non-terminals denoted by small letters, where t1 is the terminals which is denoted by the capital letters, p1 is the production in grammar, and s is the starting production in the grammar, the production where the production S1 derives AS1B or AB, where the language 2 is equals to B power n, C power n greater than or is equals to 0, where it is also having the grammar 2 into T2, P2, S2, where it is same as grammar 1, and where the production S2 is derives AB, S2 or AB. By doing union operation, we will get a resultant grammar. Let it be G3. G3 is equals to G1 union G2. We know that L is generated by a grammar G, where L is NTPS double, where N is equals to N1 union N2 union ES, where S is starting product, and T is equals to T1 union T2, and product P is equals to P1 union P2 union starting product. Starting product, yes, derives S1 slash S2 or S1 or S2. S1. It is a starting product of language 1 where it derives AS1B or AB. And S2. It is a starting product of language 2. It derives ABS2 or AB. And we result language L3 is equals to L2 union L1, that is equals to A power n B power n union B power n C power m, where n is greater than or equals to 0, m is greater than or is equals to 0. You will get a doubt like, but this how can we say that it is a closed under? Let L1 says number of A should be equals to number of B's, and L2 says number of B should be equals to number of C's. Their union says either of the two conditions to be true. So it is under closed it is also a closed CFL. So CFL are closed under union operation. We are done with union operation. Coming to the concatenation, if L1 and L2 are two context-free languages, their concatenation L1 dot L2 will be also a context-free language. So if you do an operation between two context-free languages, then the resultant will be also a context-free language. We know that. With an example, we will explain this concatenation operation like L1 is equals to a power n b power n where n is greater than or equals to 0 and L2 is equals to c power n d power n where m is greater than or equals to 0. And the starting product of language 1 is S1 that derives AS1 B or AB, and starting product of language 2 S2 that derives AB S2 or AB, where the resultant language L3 is equals to L1 dot L2 that is equals to A power n B power n C power m d power n, where m is greater than or equals to 0 and n is greater than or is equals to 0 is a context-free language. By this, how can you say there is a context-free language? I will tell you that let L1 says number of A should be is equals to number of P's and L2 says number of C should be equals to number of D's. Then concatenation says the first number of A should be equals to number of B's, the number of C should be equals to number of D. So we can create a PDF which will first push A, pop B, push C, then pop D. So it can accept the push done automator here. Hence, it's proved that CFA context-free language are closed under concatenation. So we have done with concatenation operation. Coming to the clean star operation, if L is context-free language, its clean star L1 star is also be a context-free language. Let's see example to get more clarity on this clean star operation. L is equals to A power and B power n where n is greater than or equals to 0. Product S1 starting product S1 star is derives A S1 B epsilon. Epsilon because n sometimes equals to 0, so that there then if it will become epsilon naught. L1 star equals to A power and B power n where n is greater than or equals to 0 star is also context free language. Let's see this. Starting product yes derives yes S1 epsilon naught. So by this you can get clarity like CFL are closed under clean star operation. We have done with CFL closed under operations. Let's see the non-closed under operations. So we have done with the closure operations. Coming to the non-closure operations, the first one is intersection. If L1 and L2 are two context-free languages, their intersection L1 and L2 need not to be the context-free language. It means if you do an intersection operation between two context-free languages L1 and L2, then resultant need not to be the context-free language. Let's see an example to get more clarity. L1 is equals to A power n, B power n, C power m, where n is greater than or equals to 0 and m is greater than or equals to 0. We are coming to this language 2, L2 is equals to A power m, B power n, C power n, where n is greater than or equals to 0 and m is greater than or equals to 0. Where by doing the intersection operation between these two languages, the resultant L3 will come. That L3 where L3 is equals to L1 intersection L2, that is equals to A power n, B power n, C power n, where n is greater than or equals to 0. Need not to be the context free. Why? Because L1 says number of A should be equals to number of B's and L2 says number of B should be equals to number of C's. Their intersection says both conditions need to be true. But push-down automata can compare only two. So by this clearly we can understand that it is not context free. Coming to the last non-closed operation, that is complement operation. The context-free languages are not closed under complement operation. Complement of context-free language L1, which is epsilon star minus L1, need not to be the context-free. So the same reason which what I told in the intersection operation, that applies the same here in the complement operation. So by this we can say that this complement operation is not closed under CFL. So we have done with the closure properties of context-free language. So let's see. So the most commonly asked questions in this topic is what is the difference between CFG and RE? Context-free grammar and regular expression. Lexical rules are difficult in case of the context-free grammar. Lexical rules are quite simple in regular expression. Notations in context-free grammar are quite complex as we have seen till now. Notations in regular expressions are quite easy to understand. In context-free grammar, the language is defined by a collection of productions. In set of strings is defined by case of regular expressions. By using the context-free grammar, it is very difficult to construct the recognizer. It is easier to construct a efficient recognizer from regular expression. There is no specific guidelines for lexical and synthetic analysis in case of context-free grammar, where there is a procedure for lexical and synthetic analysis in case of regular expression. I hope you got a clarity about the what is the difference between the context-free grammar and regular expression. So I hope you got a clarity on what is CFL and closure properties of CFL and where it is closed and where it is not closed under, and you got a difference between context-free grammar and regular expression. Thank you all for watching this video. Bye.